Hi guys, Becky the Science Tutor here, and in this session we're going to follow on from last session where we looked at the group 1 elements. In this one we're going to have a look at group 7 and group 0. We're going to look at similar ideas. We're going to have a look at how their reactivity changes down the group and just have a look at some of the general trends in their properties as we move down the group. So let's dive straight in. So group 7, also known as the halogens. Now they are on the right hand side of the table, so we know that these are all non-metals. And something to try to look into that long-term memory is that the halogens all exist what we call diatomically. So diatomic, break down the word di, two atomic atoms, two atoms. So when we're writing these as formula, when we're putting them into chemical equations, when we're writing symbol equations, we always write them as two. So Cl2, Br2, I2, whatever it is, because they always go around in pairs, because what they do is they share electrons with each other so that they fill their outer shell. So because they're in group 7, we know that they have 7 electrons in their outer shell. Remember that atoms want to have 8 electrons in the outer shell. So what the halogens do is they share 1 electron each, essentially completing their outer shells with each other. Okay, so we're non-metal atoms. We've got 7 electrons in their outside shell. Now remember that when we talk about patterns and their properties, we're always referring to down the group. So as we go down the group, their boiling point increases. And because their boiling point increases, this means that they become more solid as we move down the group. So fluorine is a gas, chlorine is a gas, bromine is a liquid, iodine is a solid. So they become more solid as we move down the group. They also become darker in colour down the group. So fluorine and bromine are gases. They're quite light, they're sort of green and yellow in colour. When we move down to bromine, if you think about bromine water, that gives us that orangey colour, that orangey brown. Iodine is actually incredibly sort of dark purple. It almost looks black when we look at it. Okay, so they become darker in their colour as we move down the group. So what we're going to dive a little deeper into is we're going to look at their reactivity. And to work out their reactivity, we can carry out a series of displacement reactions. Because if a halogen is more reactive than the other one, it will displace it from its compound. Okay, so if we have a look at this little setup, let me just move my noggin out of the way. What we've got here is we've got 3 salts. So we've got potassium chloride, potassium bromide and potassium iodide. So the halogens that we're focusing on is the chlorine, bromine, iodine. And then what we're going to do is we're going to react each one of those with their same counterparts in just a sort of a water solution. So what we're doing is we're essentially reacting the chlorine. We're going to react it with chlorine, with bromine and with iodine, and what we're looking for is is there a chemical reaction? Now remember that when we know a chemical reaction is taking place, we either have a change in colour, change in temperature, pH, fizzing, bubbling. We're looking for something happening. So all we're going to do is we're going to look at these different reactions, and we're just going to fill in this table with a simple tick or cross as to whether a reaction has occurred. So we've got the first 3 set up here. We're adding chlorine in, so we're seeing if chlorine, does it react with chlorine? Probably not, it's the same thing. Does chlorine react with bromine, and does chlorine react with iodine? So if I flick onto the next slide, here are the results. So big thing is, look, have we got a colour change? No reaction with chlorine, which makes sense. It's not going to displace itself, is it? They're the same reactivity because they're the same element. However, bromine has caused a change. So what the bromine has done is, the chlorine has displaced the bromine. So now we've got bromine on its own and we've got potassium chloride. And the same has happened with the potassium iodide. When we've added the chlorine water in, there has been a reaction because we've got that colour change. And we've now got potassium chloride, and iodine is now on its own. It's been displaced. Okay, so if we pop back to our table, we can say potassium chloride, when it reacts with chlorine water, does nothing. Potassium bromide does react, and the potassium iodide does react. Okay, next ones then. So we've got bromine water this time, and we're going to add them into the same three. So if we have a look, in with chlorine, there's no reaction. In with bromine, there's no reaction. Again, it's the same thing. Is bromine more reactive than bromine? Well, no, it's the same thing. So there's going to be no reaction. And bromine with iodine. This has reacted. The iodine has been displaced, so the iodine is now on its own. And bromium. That's like adding two names together, and is it like Amy and Sheldon, if you've watched Big Bang Theory, when they're shamey. Anyway, I digress. So the iodine has been displaced, and we've now got potassium bromide that have bonded together. So let's pop back to our little table. No reaction, has reacted. And in the final set then, can you predict what's going to happen? We're adding iodine to the chlorine, bromine and iodine. Do we think there's going to be any chemical reactions? Nope. No chemical reactions. Nothing happens between the three. As suspected, you probably thought, well, no, iodine's not going to react with iodine. But in the first two as well, it's not reacted with chlorine and it's not reacted with bromine. So if we go back to our little table, we have no reaction, and no reaction. Okay, so typically exam questions will give you a little table like this, and then it will ask you to conclude or to sort of decide which is the most reactive and explain why you've decided that. So in the exam question that we're going to look at, sometimes they give you like if there's been a colour change or not, but remember, if we get a colour change, we know that a reaction has taken place. Okay, so let's move down and have a look. So what we can say, remember that we talk about what happens to the reactivity down the group. So in the case of these three, we can see that chlorine is the most reactive because it had two reactions. Bromine is in the middle because it had one reaction, and iodine is the least reactive because it didn't have any reactions. So this time, as we move down group 7, the reactivity decreases. Okay. Last session we looked at group 1, their reactivity increases. With group 7, it decreases. So let's jump in and have a look as to why. So, as I've mentioned before, reactivity is all about electron structure. So here is the electron structure for chlorine, fluorine. I always forget about fluorine. Poor fluorine. I always miss fluorine out. Fluorine, chlorine, bromine and iodine. Okay, now don't worry too much about the electron structure of bromine and iodine. You are not expected to draw those because they do not fall into the first 20 elements of the periodic table. However, for the sake of explaining this and looking at this, I've displayed those structures for you. All we need to worry about is the size of the atom and how many electrons are in that outer shell. Okay, so what we're explaining, why does the reactivity decrease as we move down the group? So this time what we're wanting to do is we're wanting to pull in an electron. So remember that the nucleus contains the electrons and the protons. So our nucleus has a positive charge. So we've got a positively charged centre and we have negative electrons. And what these elements are wanting to do is they're wanting to pull that electron in to where it's got a spare space to gain that full outer shell of electrons. So they want to accept an electron from somewhere. Now the only thing that's pulling them in is that positively charged nucleus. Remember, like I said last session, think about them almost as magnets. The closer they are, you're going to feel that pull. The further you move them, the less that force is. And so the ones that are closest to the nucleus, it's easier for it to pull that electron in. The further away that they are, there's less pull, and so therefore it's harder to pull that electron into that spare spot on the outer shell, because each time we move down a level, we increase the number of shells. So just like with our group 1 elements, this is a standard answer if you get a question, why is chlorine less reactive than fluorine? Why is bromine less reactive than chlorine? It's the same kind of pattern. It's the same things that we're going to say. So let's build our answer. So why does the reactivity decrease down group 7? So we're going to say that the outer shell is further from the nucleus. There is increased shielding, or there is more shielding, because each time we move down we have another shell of electrons. And that means that it's harder to gain an electron. And this is your same general idea for whatever way round it's asking you. Why is chlorine less reactive than fluorine? Outer shell is further from the nucleus, there is more shielding, so it's harder for chlorine to gain an electron. Now the only thing I'm going to say here is be careful if they flip the question the other way. Why is fluorine more reactive than chlorine? The outer shell is closer to the nucleus, there is less shielding, and so it is easier to gain an electron. So just be careful which way round the question is posing it to you, whether it's asking why is chlorine less reactive or why is the fluorine more reactive. And just like that pattern in group 1, it's exactly the same. If you get asked why is bromine less reactive than chlorine, because its outer shell is further from the nucleus, there is more shielding, and so it's harder to gain an electron. Okay. Why is iodine the least reactive? Its outer shell is the furthest from the nucleus, it has the most shielding, and therefore it's hardest to gain the electron. Okay, so once you lock that in, it's the same repeating pattern in that answer. Okay, right, so here's some typical exam questions then. So this looks quite a meaty question. It is a level 1 question, it is a lower level question, so whether you're doing higher or foundation, this is something that you are quite likely to see. And as I said to you earlier, what they've done here is they have put in whether there has been a change in colour or not. So where we have it written in that it's changed colour, we know a reaction has taken place because we've got that colour change. Okay, so it says explain how the reactivity of the halogens changes down the group. Use the results in the table above. Okay, so we can see there, like we said earlier, we can hopefully deduce that the reactivity decreases down the group. So for mark number 1, we need to say what's going on with the reactivity. So the reactivity decreases. Okay, now we've got to explain, well, why? How do we know that? Why did we come up with that? Okay, now we can say that chlorine has two reactions. Oops, helps if I spell it right. Spell it right, I've made a mess of that, haven't I? Okay, so we're identifying, we can see that chlorine's got two reactions, bromine has one reaction. And we can say that iodine has no reactions. Okay. Okay, some other styles of questions then. So again, a sort of low to mid-level question. It's about the halogens, so this is more, there's a bit more variety in this. It's asking you about the trends as well as the reactions, etc. So how does the boiling point of the halogens change down the group from fluorine to iodine? It's just worth 1 mark. It doesn't want much from us. We don't have to explain. It just says how does it change? It increases. That's all we need to say for that one. Sodium bromide is produced by reacting sodium with bromine. Sodium bromide is an ionic compound. Write down the symbols of the 2 ions in sodium bromide. So sodium, we looked at last session, is in group 1. It's going to want to lose an electron. If it loses an electron, it has more protons than electrons, so it's going to become Na+. It's now an ion, not an atom. And our bromine wants to gain an electron. It's now got 1 more electron than protons and therefore has an overall negative charge. Okay, chlorine reacts with sodium bromide to produce bromine and one other product. Complete the word equation for the reaction. So here we've had displacement happen. Chlorine is more reactive than bromine, so it's displaced bromine out of the way and it's bonded with the sodium. So now we've got bromine on its own plus sodium chloride. Okay. Why does chlorine displace bromine from sodium bromide? Because it's more reactive. And then the final one says suggest which halogen could react with sodium chloride to produce chlorine. So what could we react with sodium chloride to displace the chlorine? When you look at your periodic table, the only one that's above and therefore more reactive is fluorine. And whether you write the word or you put the symbol, either is acceptable. Okay, so this is towards the higher end of the scale of questions, because here it's asking us to explain that reactivity. So we've really got to dig a little deeper into these. So we've got chlorine is more reactive than iodine. Name the products formed when chlorine reacts with potassium iodide. It's told us it's more reactive, so it's going to displace the iodine. So what we're going to end up with is they're just going to change around. So we're going to have potassium chloride. And iodine is going to be displaced. Oops, let me change that because that should be chloride. That's because I was thinking ahead. chloride and iodine, it will now be on its own because it's been displaced. And now we need to explain why. So first marking point. So why is chlorine more reactive? This is the flip of what we said earlier. So chlorine's outer shell, or chlorine's outer electrons, is closer to the nucleus. Okay. There is less shielding. Marking point number 2. And therefore it's easier for chlorine to gain an electron. And that's for marking point number 3. Okay, so as I say, just getting your head around which way it's asking you. Yeah, if it was why is iodine less reactive, we'd be saying the things on the reverse, that the outer shell is further from the nucleus, there's more shielding, and therefore it's harder to gain the electron. Okay then, let's have a look at the final group then. So the group 0, the noble gases. Okay, so group 0, obviously we can see they're all gases, they're called the noble gases. These exist monatomic, and monatomic meaning mono, one atom, so they all exist singularly. And the reason that they exist singularly is because they're really quite unreactive. They've got a full outer shell of electrons, and therefore they don't need to gain an electron. So because they've got that full outer shell, it makes them unreactive. They're quite happy just on their own, doing their own thing. Okay, so there's not much to know about the noble gases because they don't do very much. But although they're not very reactive, they do have some uses, and we're going to have a quick look at some of those uses so that we can apply that to the exam questions. So if you think about it, you probably do know some uses, but just might not have thought what is involved with them. So the first one, and this is a popular context for an exam question, is that argon is used in light bulbs. And the reason that we use argon is because it is unreactive. When that filament inside the bulb heats up, if it was full of oxygen, for example, that could cause the oxygen to ignite and therefore that bulb to explode. So we use argon for its simple reason that it isn't reactive. It's perfect for that. Okay, we've got neon in neon lights. So all the signs and shop windows, things like that you see, neon lights inside of them. And then we've got helium. Yes, we can put it into our birthday balloons. Yes, we can make our voice sound really silly, but it does have lots of other uses as well. So the one that's shown here is that it is in a weather balloon, and that weather balloon will obviously rise up and will monitor the atmospheric pressure and humidity and all the other things it's travelling up, but we're using that helium because it's lighter than air and therefore will cause that balloon to travel upwards. Okay, so just a very few simple straightforward questions for group 0 because there's not that much to say about them because they don't do very much. Okay, so the name of the elements in group 0 are the noble gases. Thank goodness that Mendeleev decided upon them and put them in the end column. Which statement about the group, about the elements in group 0 is correct? Okay, their boiling point decreases increases down the group. I was trying to read two statements together there. Neon is in group 0. What type of particles are in a sample of neon? Well, they are atoms. They're not ions because it hasn't lost or gained any electrons, so we haven't got an imbalance between protons and electrons. And it's not a molecule because they exist monotomically. They're quite happy sat there on their own. So explain why group 0 elements are monatomic. And that's because they have, so 2 marking points. The first marking point is that they have a full outer shell. And so they've got no tendency or no reason, or they don't need to gain electrons, however we want to word that. Okay, they've got that full outer shell. They're quite happy as they are. They don't need to gain any or lose any to get that full outer shell, because they've already got that. Okay, here's a lower level question about light bulb. As I say, it's a very, very common question because they can first of all ask you about atomic structure and then lead it into a use of them. Okay, so here first of all it says an argon atom has a structure shown. Use the words from the box to label the particles of the atoms. Each word should be only used once. So if I ask you to use words from the box, please, please, please do use words from the box. Don't make up your own. They are there to help you. So on the outside then we've got 2, 8 and 8. These are the electrons. We've got 18 something, but it's got a plus sign in there, positive protons. And then the ones that are often shaded in, haven't got a symbol in them because they have no charge, they are neutral, is a neutron. So argon is unreactive. Why? It has a full outer shell. Whoops, squeeze a little A in there. Has a full outer shell. Doesn't need to gain any, it's quite happy and stable on its own. And then a similar style question, but just a little higher in the demand and the level of the question. Okay, so we've got, the diagram shows an electric light bulb. When electricity is passed through the tungsten filament, it gets very hot and gives out light. What reaction would take place if the hot tungsten was surrounded by air? So if there was air in there rather than the argon atmosphere, we would have oxygen in there. Yes, we're going to have other different gases that are in the atmosphere around us, but we're going to have some oxygen in there, and that heat is going to cause a reaction with the oxygen. Okay, so what reaction would take place? Ultimately, we're going to get combustion. Because we've got the fuel, which would be the sort of the wire, we've got the heat as it's heating up, and we need a plentiful oxygen supply for combustion to occur, and we've got plenty of oxygen if it was filled with air. So something along the lines of that it would oxidize, it would burn, it would combust, it would make an oxide, however you want to word that answer. And then the final question, it says state why argon is used in a light bulb and explain your answer in terms of the electron structure. So why do we use it? It is used because it is unreactive. So marking point 1 is for state why. Okay. Then we need to explain in terms of the electron structure. So I'm going to say it's because it has a full outer shell and it does not need to lose or gain electrons. Okay, so marking point 1 is that it's unreactive, marking point 2 is that you've identified it's got a full outer shell, and therefore for marking point 3 it does not need to lose or gain electrons, therefore it does not react. Okay then guys, hope you found that helpful, and as always, if you would like any further support, please do not hesitate to reach out, and I'll see you next time.